In this video, we'll be rationalizing binomial denominators. Just like before, when rationalizing, the whole point is to eliminate the radical in the denominator. When you have a binomial, there's a little bit more work to do, but less thinking. We don't have to try to think what creates a perfect square or cube like we did when we had a monomial denominator. Every single time the denominator is a binomial, you want to multiply the numerator and denominator of your fraction by the conjugate of the denominator. The expressions a plus b and a minus b are called conjugates. I always think of it as the exact same thing, but the middle sign is changed. Now, a plus b and a minus b might jump out at you as something you recognize. When we factor the difference of two squares, we get a plus b and a minus b. Well, we're actually going to use some of that when we are rationalizing the denominator. We're going to be multiplying conjugates together, a plus b and a minus b. Look at what happens when we do this multiplication. A squared minus ab plus ab minus b squared. And then we combine like terms that we have in the middle. Notice that negative ab plus ab cancel out, and we're left with just a squared minus b squared. Anytime you're multiplying conjugates together, the middle terms always fall out. So when we're multiplying conjugates, really all we have to do are multiply the first two and the last two together, because we know that the middles are going to fall out every time. We can use that shortcut in these next examples. So let's rationalize the denominator. 2 over the square root of 3 plus 2. Since I have a binomial in my denominator, I know that I'm going to be multiplying the top and the bottom by the conjugate of the bottom, which is the exact same thing, but the middle sign is changed. So we're multiplying top and bottom by the square root of 3 minus 2. I'm going to put a bunch of parentheses around here since we need to distribute. There's no shortcut for the numerator. So let's multiply. We get 2 square root of 3 minus 4. But in the denominator, we're multiplying conjugates together, so we can shortcut it. All we need to do is multiply the first two together and the last two together, because the middles are going to fall out every time. If you forget that shortcut, no big deal. You can do a full FOIL. You'll just find that your middle terms fall out every time. Multiplying the first two together, square root of 3 times square root of 3, square root of 9. And then I have a positive 2 times a negative 2, minus 4. And then we simplify any radicals that we have. Square root of 3 can't be simplified. So here in the numerator, we have 2 square root of 3 minus 4. In the denominator, the radical had better simplify out. Remember, the whole point of what we're doing is to eliminate the radical in the denominator. So the square root of 9 is 3. So we have 3 minus 4 in the denominator, which is negative 1. And we want to simplify this. Anything divided by negative 1 is the opposite. If you're more comfortable, you can break it up into two separate fractions and then simplify. We're going to get negative 2 square root of 3 plus 4. In our next example, we have a binomial in both the numerator and the denominator. That doesn't affect our first step. We have a binomial in the denominator. So to rationalize, I'm going to multiply the numerator and denominator by the conjugate of the denominator, which is 2 square root of 2 minus 1. Again, I'm going to put a bunch of parentheses here so I do my distribution correctly. There is no shortcut for the numerator. We're going to have to do a full FOIL here. Y square root of 2 times 2 square root of 2. That's 2y on the outside. 4 underneath our radical. Y square root of 2 times negative 1. Negative 1y square root of 2. Negative 1 times 2 square root of 2 is negative 2 square root of 2. And negative 1 times negative 1 gives us positive 1. In the denominator, we are multiplying conjugates together, and we know the middle terms are going to fall out, so we can multiply just the first and just the last together. 2 square root of 2 times 2 square root of 2, it's 4 square root of 4, and a positive 1 times negative 1, minus 1. We want to simplify anything that we can. In the numerator, I see that I have a perfect square, right? The square root of 4 is just 2, so really that's 2y times 2. It's going to be a 4y. My square roots of 2 do not cancel or simplify. In the denominator, I know my radical is going to simplify. It has to. Whole point of what we're doing. Square root of 4 is 2. So we have 4 times 2 minus 1 in the denominator. So that's 8 minus 1, which is 7. You may have noticed that we have like radicals in the numerator, those square roots of 2. But notice that what we have in front of the radical, the negative y and the minus 2, those are not like terms. Technically, we could combine these like radicals, but that would involve factoring out a square root of 2, and I think that's unnecessarily complicated. So we're not going to combine these. We're going to leave them as they are. We're going to look to see if we can simplify our fraction overall. We can't, so that's our answer. Our last example here. We'll multiply our numerator and denominator by the conjugate of the denominator, which is the square root of 2 plus 5. Add our parentheses. No shortcut in the numerator, so we'll have to do the full multiplication. 3 times square root of 2 is 3 square root of 2. 3 times 5 plus 15. Square root of 2 times square root of 2 gives us square root of 4. And then square root of 2 times 5 gives us 5 square root of 2. In the denominator, we're multiplying conjugates, so all we have to do is multiply the first two together and the last two together. Square root of 2 times square root of 2 is the square root of 4. Negative 5 times 5, minus 25. We want to simplify any radicals that we can. The square root of 2 does not simplify in our numerator, but we do have the square root of 4, which simplifies down to 2. And we also have the square root of 4 in the denominator, which simplifies down to 2. We have 3 square root of 2 plus 15 plus 2 plus 5 square root of 2. And in the denominator, we have 2 minus 25. We want to combine any like terms that we have. We do have like radicals in the numerator this time that have like coefficients, so we want to put those together. I also have constants in the numerator and constants in the denominator to combine. Starting with our radicals, 3 square roots of 2 plus 5 square roots of 2 is 8 square roots of 2 plus 17, and in the denominator, negative 23. You want to try to simplify your fraction overall. Even if we broke it up into two separate fractions, 8 doesn't simplify with 23, neither does 17. We have a final answer of 8 square root of 2 plus 17 over negative 23.